Yes, kindly record the meeting.
Yes, it is. It is now recording, so we can make that recording available to you later.
Okay, thank you, thank you. You can now proceed.
So, once again, hello and welcome to the first day of our PolyAnalyst basic training. My name is Jeffrey Palin. You can just call me Jeff. And I am a data analysis consultant with Megaputer Intelligence. And I'll be the one giving training on each of our 5 scheduled sessions. Please feel free to interrupt me at any time during the training to ask me questions, or if you need me to, slow down, re-explain something, or show something in the program again. But before we start learning about how to operate the software itself, let's start with a brief introduction to the function of PolyAnalyst that make it a useful tool for data analysis. So PolyAnalyst is an all-in-one tool, and what we mean by that is that you can use just PolyAnalyst from the start to the finish of your analysis. Because you see, PolyAnalyst lets you load in your data, and you can load from multiple sources and from different types of sources simultaneously and automatically. We can do data cleaning and data manipulation. So we can do things like spell checking, aggregations, and substitutions. We also have tools for both structured and unstructured data analysis, such as document categorization and keyword extraction for text analysis, and clustering and prediction models for structured data. And in the end, we can create visualizations and publish reports, all without ever leaving PolyAnalyst's graphical user interface. So I mentioned structured and unstructured data in the previous slide, and you may hear me use these terms as we go along, so let me clarify what they mean. Structured data refers to data that is organized and formatted based on a predefined schema so that it's easily understandable and searchable by a computer. This is usually what we see in tables in Excel, for example. We usually have numerical values or categorical values, i.e. a finite number of options or categories that we can choose from. Unstructured data, on the other hand, does not follow a predefined schema or data model. It typically refers to things like free text or natural language when we use the term unstructured data. So now text itself does have an internal organization that we as humans can understand and analyze because we have the relevant linguistic knowledge. But natural language is not easily understandable by computers. So as humans, we understand that these two examples here, the claimant did not brake in time and rear-ended the insured, and the blue Toyota was hit on the rear when the Volvo failed to brake in time. These are two similar examples of car accidents, but a computer doesn't automatically know that type of information. So we need to extract that information from the text in a format that is more easily understandable and searchable by the computer. So really, the goal of unstructured data analysis is to turn it into structured data analysis, or turn the unstructured data into structured data so that we can perform structured data analysis on it. This is just a brief look at the topics we're going to cover in the training schedule. So we're going to have a brief overview of PolyAnalyst and its interface. Then we're going to go step by step through a sort of default text analysis workflow where we load data, clean data, do data-driven and analyst-driven analysis, and then look at web reports. And then we have a few miscellaneous topics at the end, and we'll have time for questions as well. This is over the course of all 5 days. So first, we want everyone to be able to have access to PolyAnalyst itself during the training. So I know we had some issues with this last week. Has everyone had a chance to install PolyAnalyst and get it up and running? My understanding is everyone is running a local copy on their own laptop or workstation. Have we gotten this resolved, or do we still need some work here?
Yes, we can carry on.
Okay, we'll just carry on. So let me show a brief demonstration of importing. And I'll talk about this a little bit more in the PowerPoint slides. But I think there may have been some confusion last week when I was talking about the thin and the thick client. Last week I was using the thin client, which is the browser here. But I believe my understanding is that you guys will be primarily using the thick client. So that's what I'm going to be using going forward.
Yes, we are going to use the thin client.
All right. So it's not really, they're basically the same thing, but here we have PolyAnalyst Client Lightweight. That is the thin client. That'll open it up in your browser. And Analytical Client here, this option will open up the actual application here. So let me just log in. Now, if you want to import a project, there's this.
Hi, Deb. Hi, Deb.
Hi.
We are using the thin client.
Oh, you guys are using the thin client.
Yes.
Okay, someone told me you're using the thick client. Okay, that's okay. I'll switch to the thin client. Oh, I want to use that browser. Let's use Chrome. So here I have the open project window open. If you want to import a project, there's this folder with a sort of green arrow on it. You can click upload and import. And then you can browse for, let's say, either PA6 files or PS6 files. The project we're going to be working on is this basic training 2622 PA6. So I would click open, and I have already, and you can click import to start, but and some of you may have already done this as well. I've already imported a copy of that project myself. I'm just going to double click it to open it. You should see something like this once you've imported and opened the project. So this first session, we're going to walk through an overview of the system. Some of this material may seem very low level, but I'm assuming that we have attendees from a variety of backgrounds, and I actually assume most of you haven't really seen PolyAnalyst very much. So I want to make sure that everyone's on the same page. And as I said before, for each major topic I cover, I'll be presenting slides and then showing some hands-on. However, you are welcome to have the project open while I'm presenting the slides so that you can do some testing on your own. And a good place to do that testing, you can test wherever you want, but there is, as we'll see in a moment, a place called there's a sand in this project. We've created a space called a sandbox where you can mess around in. You can of course mess around anywhere, and it's only a sandbox because we called it a sandbox. Anywhere can be a sandbox. So when we open the project, you should see something like this. To get to the sandbox, you can double click this icon that says day 1, and then you'll see something like this, and there'll be another icon here that says sandbox. You can just double click that. It'll give you just a blank space to keep your testing work separate from the rest of the training project. Now, in general, I think you'll find that a lot of PolyAnalyst interface is pretty intuitive as far as the basic platform goes, but sometimes there is more than one way to do a particular operation in PolyAnalyst, and this is what we're going to, well, one of the things we're going to show here. With that, let's get started with an overview of PolyAnalyst and how it works. So we'll first start out with a high-level overview of PolyAnalyst, talking first about its architecture and how the different components communicate with each other. So PolyAnalyst is a client-server system. If you haven't heard this terminology used before, let me briefly explain. Client-server models are just a way that you can set up a computer network. And a lot of what we use on our computers and smartphones acts in this manner. So when you use Microsoft Outlook to send and receive email, or when you open your browser and visit a website like Amazon, these are client-server systems as well. So in the first case, your email is hosted on a separate server, and you access that server by opening your client application, either on your computer or maybe on your phone. And when you request to open or send an email through the email client application, it sends that request back to the server and has the server actually perform the action. So PolyAnalyst isn't that much different from that. We have the PolyAnalyst server environment that performs all the calculations and tasks, and we connect to the PolyAnalyst server using a PolyAnalyst client, and we use the client to pass requests and tasks we want the PolyAnalyst server to perform. So a client-server model is highly efficient at handling advanced analysis. This is because it allows one machine with ample resources to run all the processes, and then your client computers that typically have less computing process powers can remotely access the server. Of course, I don't know if this is if this is always going to be the case for all of you, but you're currently running servers on your local machines. So that works the same way. You're just running the server on your machine and then also opening the client on your machine. So it's a local connection. But like I said, one of the advantages of having the option of client server connections is that you can have one powerful machine run the server and then have multiple clients all connect to it. Let's see. Yeah. So this diagram here on this slide is a more detailed version of PolyAnalyst client server architecture. So in the center, we have our separate Windows server that is running the PolyAnalyst server, which is the agent that actually gathers, analyzes, and stores the data. On the left, we see how outside data sources and databases can be accessed by the PolyAnalyst server. And over on the right, we see some examples of client applications you could use to pass requests to the PolyAnalyst server. Now, although we'll be conducting much of this training using, we're going to be using the thin client. Yeah, skip that. Let's see. There is also some API compatibility for sending requests to the server. And let's see. Okay, so now let's go over how we start the PolyAnalyst server and connect to it with the PolyAnalyst analytical client. So we'll first start out with a high-level overview. Okay. So starting the server. Let me talk through an example setup and how you'd start PolyAnalyst server and connect to it with the PolyAnalyst analytical client. Now, these basic steps will be the same regardless if your PolyAnalyst server is running on a separate server computer or on the same computer that's also running the client application. What would be different is in which computer you perform the steps on in that case. So we first need to start the PolyAnalyst server application. The recommended way to do this is to first start the PolyAnalyst Tray Assistant application. So you can just do a search for PolyAnalyst and click on Tray Assistant to start it. For everyone using their own laptop as their server, they can start the Tray Assistant on their laptop. But once you have a dedicated server, you would need it to remote into the remote server to start the server on the remote server. Once you launch the Tray Assistant, you can go to the tray at the bottom of your screen and right-click it. Click on the tray icon, and it'll bring up this contextual menu. You'll see a number of options for launching the analytical client and also the administrative client at the top of that menu. But then near the bottom, you'll see options to start and stop the PolyAnalyst server. So here we can see that the option for starting PolyAnalyst server is grayed out, which means that it has already been successfully started. If the start PolyAnalyst server was black, then we could click on it to start the server. So another way you'll know PolyAnalyst server has been successfully started is that it will give us a confirmation or when you start the server, we will get a confirmation message here that says how many days are left on the license. Of course, if you are not the person at your organization responsible for maintaining a separate server machine, you don't need to worry too much about this starting the PolyAnalyst server step. But it may still be good for you to sort of understand what's going on behind the scenes. So let's see. So once we know that the PolyAnalyst server has started, next we want to start our client application. In this case, we're just going to go with the analytical client. So here we're going to click on a user machine that's connected. In this scenario, we're still using a remote connection, so via the network to our Windows Server machine. We're going to click on the Tray Assistant, and this time we're clicking on Analytical Client. This is for the if we want to start the thick client. And this information here is it'll be similar to what we see in the thin client, but we can go over it here. So it has username and password, but also settings. So to specify the connection properties, we can click on settings. For example, we would want to provide the server location we wish to connect to on this tab here. Now, as I believe everyone's running on their local machine, the server address would just be localhost typically. But you may need to connect via LDAP credentials. But I don't. Are you all planning to use LDAP? Do you know what that would? Do you know what that? I don't know. Are you using LDAP?
No.
So LDAP uses sort of if your company has Windows credentials for its users, you can use those credentials to log into PolyAnalyst. But if you're all using local installations, then it's less likely you're using LDAP. Is that correct? Are y'all just logging in like as administrator?
Okay, we'll just focus on that later. Just use the administrator one.
Sorry, what?
We'll use that later on.
Well, I just want to make sure I'm giving you information that's useful. Are you logging in just as administrator right now, or did you make accounts, or are you using LDAP?
Yes, administrators.
Okay, everyone's just logging in as administrator. Okay, so no, so you're not using LDAP right now. That's fine. Okay, and then for the thin client, similarly, we can go to the tray assistant, or you can just have, once you've opened it up, you can just bookmark this address here. You can, and then you can access it through your browser without using the tray assistant. And you actually don't need to have any PolyAnalysts. Well, if you are connecting to a remote system, then you don't need to have PolyAnalyst installed on your own computer. That's actually one of the main benefits of the thin client, is that you only need to maintain the software on one server. But because you're all just using local copies, you don't get that benefit, but it's still fine. It's effectively the same as the thick client. Right, so you can just have something like that, but bookmarked. When you connect to the server, you might get a warning message like this in your browser, but you don't have to worry about that too much. This is just saying that the website you're going to in your browser doesn't have a certificate, a security certificate that your web browser recognizes. And of course it doesn't, because the PolyAnalyst server you're running isn't meant to be like publicly accessible. You actually can get a certificate if you want to, but this is just your browser saying that it doesn't know what the heck this site is that you're going to. So creating and opening a project. So if you didn't see the welcome menu when you open PolyAnalyst, or you accidentally close it before selecting an action, all you need to do to open or create a project is to click on either the new project icon here in the top left. Alternatively, you can click on the file menu. You know, this UI is in the thick client, but well, it's similar in the thin client. I'll show it in the client. You know, I thought you guys were going to be using the thick client, so these graphics are all using the thick client. We'll go through this, and then I'll go through it again in the client itself. So we have the menu bar at the top. The node panel over here is where we will search for different nodes to add to our workflow. We have the flow chart and the results pane here where we actually built the project. Then we have a window selector and a map and a task list. Let me... So the thin client looks a little bit different here, a little bit cleaner. So instead of having all of those items at the top with file and stuff, there's just a drop-down menu here where we can use new to create a new project, or open. Let's see what else is it showing. Oh, task list. So the task list is now up here in the top right. So if we're executing some tasks, they'll appear here with progress bars. And there's not really a map at the moment, I don't think. That's okay. All right, so adding nodes. So we saw there's a workflow, or what we might call the script in PolyAnalyst, which is composed of what we call nodes. And we can add these nodes in a couple of different ways. One way we can add nodes is simply by clicking on a node in the node panel and then dragging and dropping the node using the mouse directly into our flowchart. If you use this option, you can either scroll through the nodes in the node panel or find the one you want under the relevant category, or you can use the search field to quickly find and specify the node that you want. The other way is to add a node is to right-click anywhere on the workflow, and then there will be this pop-up menu. We can click Add to select a node from the relevant category there. And if you wish to delete a node, you can just right-click on a node and select Delete. Let me show that. Right-click and select Delete, or you can simply select it and press the Delete button. And similarly, you can right-click and do copy-paste, or you can select it and use Windows keyboard shortcuts like Control-C for copying, Control-V for pasting, and also Control-X for cutting. So let's... and now one very important aspect of PolyAnalyst's UI is that we need to connect nodes. So nodes are connected to one another directionally. So as one node connects to another node, that we'll visually be able to see the flow of data. So once we have some nodes on the flowchart, we're going to need to connect them. So our nodes can only interact with each other through these directed connections. So let's say we have these two nodes on our workflow. Now, if we want to connect them, we simply hover over the first node's icon with our mouse until you'll see a black arrow or black triangle appear. Then we can click that arrow with our mouse and drag it over to our other node. And then we let go, and then they become connected. And as you can see, the connector has an arrow on one side, so that indicates the direction. So one thing to consider is that not every node can be connected to every other node. So for example, you can't connect a data source node directly to another data source node. So if a node won't connect when you drag the arrow over it, it might mean that that's not a compatible sequence of nodes. Also, once the nodes are connected, we need to make sure the node is configured. You configure a node in the node's properties, and you'll find that some nodes need more configurations than others. And once everything is configured properly for our newly connected node, we can double click on the node or right click and select execute. Now, if you want a little more control over how many nodes are executed at that time, you can instead choose the execute to here option from the pop-up menu. And once that second node has been successfully executed, it will look like this. Now, if you want to disconnect two nodes without deleting the nodes themselves, you can right-click on the line connecting them to and say unlink, or you can left click it and then press delete on your keyboard. So you probably noticed in the last slide how each of the nodes had a small symbol here in the lower left corner of their icon. If I go back, you'll see that the first icon, the NHTSA complaints, in most of these has a little green checkbox. The other one has either a red circle with an X or a yellow circle with an exclamation point. That's what we're talking about here. So each of these node icons has a little symbol in the bottom left, and that symbol denotes the status of the node. So this first one, a small red circle with an X, it means that the node is either unconnected or not configured. The second one is a yellow circle with an exclamation point. This means that the node is on standby, which means that it has been configured but has not yet been executed. Then we see the green check mark. This means that the node has been successfully executed. And then we actually have a fourth one that looks like this, where it's a big red X on the node. This means that the node attempted to execute but failed, and there should be some associated message in the taskbar telling us what caused the failure. And finally, we might see a node that has a triangle with an exclamation point here. Actually, at the triangle is at the top. This indicates that the node is successfully executed, but there were some errors that didn't cause the whole execution to fail. And those errors we can view in a log by right-clicking on the node and going to View Log. So if we right-click that node, there's an option there down in the middle called View Log that'll show us what errors occurred that caused that triangle to appear. So this is what the workflow of a typical project might look like. As you can imagine, these can tend to get complicated and difficult to navigate if we have many different tasks and types of analysis we want to perform in one project. This is especially the case for people seeing a project like this for the first time and trying to, maybe it's not their first PolyAnalyst project, but if you view a project built by someone else, you won't immediately know what the purpose of every node and every section of the project is for. So one tool we have that can help with this is what we call our group nodes. You can think of group nodes like subfolders that contain parts of the workflow that we don't want on the main interface. So as a good practice, it is highly recommended to use group nodes to organize the different parts of your analysis. So grouping nodes helps you maintain a clean and nicely structured workflow that's easy to follow. Now, another organizational technique for the flowchart is to rename the nodes and group nodes. This is because the default way nodes and group nodes are named in PolyAnalyst is often just the base name of the type of node, and sometimes with a number appended to the name if there's more than one of that same type of node in the project. So in another place and in cases where the same node can be used to transform the data in different ways, it might not be clear what action was actually taken without actually looking at the properties. So this is why it's good to rename your individual nodes as well as your group nodes with something that describes their content or their purpose. So how do we group nodes? So for example, let's suppose we want to group these two nodes at the top of this workflow. So these two here. How do we take those two nodes and turn them into one, put them into the subfolder called Entity Anonymization? So what we do is we need to select, well, let's see. We first need to have at least one node in order to create a group. You can't create them. You can't create a group node and then or without something in it first. So we need to highlight one or more nodes, and then we can right-click them and select the group option from the pop-up menu. And then if we want to, we can rename our group node with something more descriptive. And if we want to ungroup the nodes, it's more or less the same steps. We right-click and select ungroup from the pop-up menu and click the ungroup button in the toolbar. So let me show this in client. So let's do, I'm just going to do a quick example here. So let's say I have these 3 nodes. If I want to group these 2 nodes, I can just highlight them, right click, go to group. And if we want, I can right click, rename it, test. And now we have this group node. If I double click it, we can now see those 2 nodes that I had highlighted. If we want to change what level of the project we're looking at, there's a couple ways. So up here at the top, there's sort of an address list here with root and then test. So if I click on root, it'll take us back to the top. You can also click this icon here. So incoming connection point. That'll also let us change what level of the project we're looking at. Okay. Okay. So when we open a group node, we'll see a basic structure like this, with your series of nodes linked to an incoming and, in some cases, outgoing connection point. Now, it's important to note that this node grouping can have no more than one incoming connection point and no more than one outgoing connection point, regardless of how many workflow branches we may have in our group node. That doesn't mean that the group node can't connect to more than one node outside the group, only that you have to choose a single node from inside the group to be the output point. So let's do it. Let me do it in client. So let's say there's a node here. So first we need to make sure that we have outgoing links allowed. So now I've created this. And now no matter how many, let's say there's a big complicated project in here. So I'm just going to add a bunch of random nodes. There's only one outgoing point. We have to pick one of these nodes to sort of represent the output of this group node. And only one node can be that representative. So maybe it's this one. So we take this one that we want to be our final output from this group node, and we put it to the outgoing connection point. And now this group can connect to other nodes. So even though it only has one outgoing connection point, it can still connect to any number of other nodes outside. It's just basically what we have here is equivalent. If I just if we ungroup it, we'll see that it's just continuing the linear flow. So if we ungroup, we still have the same thing, but this one that was our outgoing link, now it's just directly connected to these two. So, and we can go back. I can select all of these, right-click, group. And now the system, because that node had those connections already, now it already knows that that is our outgoing connection point. Okay. So let me sort of cover that from the PowerPoint perspective again. So sometimes when we create a group node, we might be missing an incoming or outgoing connection point, depending on how we formed our group node. So as you can see here in this example, we have an incoming connection point, but we don't have an outgoing connection point. So let's say we finished with our data-driven analysis, which is what we're doing here. And we want to now connect this group part of the workflow where the main workflow is. So in order to continue that analysis, so what we want to do is right-click anywhere on the flow chart, inside the group node at least, and select the can have outgoing links. Make sure that's check marked. That will create our outgoing connection point. And we now, so now our group node has an outgoing link that we can use to connect it to another node or branch. And we do, as I said before, we need to select one node to represent the outgoing connection point. Okay. So then our next topic is going to be execution waves. So now that we've covered some information about the graphical user interface of PolyAnalyst, let's talk a little bit about the order in which nodes are executed and how PolyAnalyst gives us some control over the execution. So because the execution of nodes can happen pretty fast when demonstrating it in the client, we're going to first look at it through, graphically in the PowerPoint. So let's pretend that each of these dots is a node where yellow ones are unexecuted and green nodes are successfully executed nodes. So let's say we have a single branch of nodes with 4 nodes in our workflow. The execution wave for this series of nodes will start from, in this case, the leftmost because the arrows are pointing to the right. And it will continue sequentially to the right. So first node will execute, and then the next one, and then the next one, and then the next one, which is probably what you would expect. But what happens if our workflow has more than one branch, like in this picture? In this case, the execution of the nodes will happen from left to right on each branch of the workflow at the same time. So like this, it will start, but then it'll split off and they'll sort of go at each branch attempting to be simultaneous. So why do we care about execution waves? Well, in PolyAnalyst, there are different ways to execute a series of nodes. So for example, maybe we have a series of nodes here that I don't want to execute in a wave. So let's say that we decide to make some modifications to this node in the middle here, but this last node in the workflow is something computationally intensive that maybe takes a long time to execute. So in this case, we probably want to make sure that we are satisfied with the changes that we've made to that middle node before we re-execute the nodes that are downstream, including the computationally intensive node. So we want to we're in practice, we're going to continuously re-execute that middle node multiple times until we're satisfied with the result. And we don't want to have to wait for that last node to execute in between each of our different attempts to make the middle node how we like it. So how can we do that? Well, PolyAnalyst gives us control over the execution wave with two different options. So one is execute and the other is execute to here. So the default execute option executes any unexpected nodes up to and including the selected node, and then continuing downstream for all unexecuted nodes. So for example, if I right click on the node and select execute for this third node, it will execute that node and continue executing down the workflow, which is what we saw before, but that's not what we want now. This also happens if you just double click a yellow node. So if you double click a yellow node or right click and say execute, or if you are looking at the properties of a node, there'll be an execute option in that window as well. That will execute that node and everything downstream. However, there's another option. We have an option here called execute to here. So if you right click a node and you click execute to here, it will execute everything before that node and that node, but not anything after it. So that gives us a little bit more control over what gets executed. So if we revisit our workflow that had two branches, if we right click this node and select execute to here, it will only execute these two nodes. It'll execute the nodes before it because it needs the output of those nodes to execute itself. And then it will execute, and these nodes will be unexecuted. Then if we want to only execute to the top of branch, we can double click or right click and execute this first yellow node here, and that will execute all of that branch while leaving our other branch unexecuted. Okay. Does anyone have any questions about that? Okay. So the next thing I'm going to talk about.
First, you can always ask you to clarify.
Sorry, what? Sorry, if someone had a question, they can speak up. Otherwise, I'm going to move on to dictionaries. Okay, let's talk about dictionaries. So the last thing that we're going to cover in the overview section of...
There was a question in the chat.
Oh, in the chat? Sorry, let me... Can we repeat the last part? Sure, let me briefly cover execution waves again. So imagine we have our project, which consists of nodes that are linked together directionally. But just because you have a node and you have configured it doesn't mean that the action has actually been acted. Or let's say you have like a spell check node that changes the text of your data to correct the spelling mistakes. Just because you have a configured spell check node doesn't mean that you've actually changed the data yet. You have to actually execute the spell check node to actually make that change to the data. And the changes to that data only exist in the workflow at the point of the spell check node and afterwards. Now, there are essentially two ways to execute nodes. Well, there's different ways to start execution, but there's two types of execution. There's the default execute, which just executes everything. If there's any upstream nodes that need to be executed, it'll execute those. It'll execute the node that you were working on, and everything downstream, all branches will all execute. That's what execute does. Just executes everything. But sometimes we want to be a little bit more careful about what we're executing. And one of those is this example here, where we want to fiddle around with the node in the middle here, this third node. We want to try out a bunch of different settings to get the exact results we want. But that last node, that fifth node there, maybe it's something very computationally intensive, like a neural network or something. Maybe it takes an hour to execute. We don't want to make a tiny change in the middle node and then click execute and wait an hour for the neural network to update, and then go back to the middle one and make another little change, and then wait for the neural network to run again. So that's what would happen if we use the default execute command. Instead, we can use execute to here. So if you right click that third node and say execute to here, it'll only execute the nodes up to that point and nothing after it. So if we go to this split branch here, where we have two different branches, if we select this node and say execute to here, first it'll only execute that one and the node before it, but won't actually do any of the two branches. But then let's say we want to execute all of the top branch. We can do that by just double clicking that first yellow one, and that will initiate a default execute to execute that node and everything before it and everything after it. But that doesn't include this other branch. So that branch on the bottom will remain unexecuted because those are not inputs for the node that we just executed. It doesn't need any input from those because they're from a separate branch. So they're not included in the execute part. Does that make sense? Okay. So moving on to dictionaries. So this is the last part of the overview part before we, get more into the actual client itself. You can think of dictionaries as an internal knowledge base that's used behind the scenes in PolyAnalyst. So dictionaries play an integral part in the function of many of the different nodes in PolyAnalyst, especially the ones focusing on text analysis. So when we talk about dictionaries in PolyAnalyst, we're referring to these structured lists of words or phrases. Some dictionaries define word relationships in a hierarchical organization. For example, synonyms, hypernyms, hyponyms. Other dictionaries can provide lists of related words, such as the different misspellings of a word. These dictionaries can also include information about other properties of words, for example, if they're nouns or adjective, or for a dictionary of human names, maybe whether a name has a higher probability of being a male name or a female name. In other words, dictionaries add some contextual and semantic information that's important for making our natural language processing more accurate. Now, PolyAnalyst conveniently comes with a set of default dictionaries already installed. However, we need to create a domain-specific or if we need to create a domain-specific or project-specific dictionary, we also have the ability to create custom dictionaries as needed as well. And additionally, these dictionaries are accessible in multiple venues. So you can either be stored as a server level dictionary, so we can access them across multiple different projects, or they can be saved as a project-specific dictionary, so that you don't have to get confused when you're working on other projects if that dictionary really is only related to a single project. So these are some of the different types of dictionaries, and as we can see, there are quite a few. When you first start out using PolyAnalyst to build projects, you might not realize just how helpful these different dictionaries are to your analysis. For example, you might be working with some insurance claims data, and in your industry, there are certain abbreviations agents use all the time. So this is where creating a domain-specific synonyms dictionary could be helpful. Or maybe there's a number of different ways to describe an automobile collision in a claim, such as hit, struck, or collided, and you want to search the text for those words, but you don't want to have to search for every different version of every word every time. Well, you can create a custom dictionary that links all those words together in a single class so that you can easily reference all of them with just a reference to that dictionary. We will talk in more detail about the dictionaries in PolyAnalyst later when we get to the different nodes that make use of them. But for now, we'll just take a closer look at how to access and manage dictionaries in PolyAnalyst Dictionary Manager. Let's see. So there are 3 ways to open Dictionary Manager, and let me check this. Hold on. Let me. Oh, come on. I want to make sure in older versions, the web client didn't have a complete dictionary manager. So I just want to double check to see if this newer version has that working before we get into it. Let's do. Okay, everything's good. So once again, this UI is a little bit different because it's taken from the thick client, but we'll go over it in the thin client as well. So there's a couple different ways to open the dictionary manager. There's an icon or from the drop down, or there's a shortcut Control-D. And you'll get to a UI that looks like this. So on the left, we have a list of the dictionary categories, and they're separated into the server dictionaries and the project dictionaries. This is for mostly for the pre-installed dictionaries. The pre-installed dictionaries are all server level dictionaries. So any new dictionaries you create, you'll be able to decide whether to store them as a server dictionary or with the project you're working on. So just here on the screen, we have the human, or under server dictionaries, we have human names selected, and there's 55 different dictionaries because there's a dictionary for each language here. And also the dictionary description, sure. And finally, on the top, we can see there's a toolbar. Here we have a different icon, including a very important option, the language option. This is very important because different languages have different dictionaries. I'll show that in a second. So when we look for dictionaries or create new dictionaries, we need to make sure to have the right language selected. And by default, it is typically set to English. So we'll go more in depth about dictionaries and the dictionary manager more when we actually need to edit a dictionary for some of our text analysis nodes. So let's here. So if I Control D will open up a new tab like this. We can also go here to Dictionary Manager. We'll also open up this new tab. So here we have server dictionaries. These are all the default dictionaries that come with PolyAnalyst. So any dictionary that looks like this just says, default. That's it. That's a default dictionary. And then for project dictionaries, most of them are going to be empty, or well, they should. When you have a new project, they should all be empty typically. For this project, I have created some project level dictionaries, though. However, all right, let's look at the link. So up here we have English. Oh, you have to click on this. If you want to change the language, you have to click this little icon here. And this lists all the different languages that PolyAnalyst is compatible with. And each option has a completely different set of dictionaries. So for example, if we're looking at, I don't know, semantics here, these are all English. If we go to German, we don't have any semantic dictionaries in German. How about for Turkish, Dutch? I guess we don't have. The semantic dictionary are probably geared towards English, but there should be a statistics dictionary for everyone. Yeah. So even though they all have a statistics dictionary, the contents of that statistics dictionary is different for each language. So here we have French. If we look at the statistics dictionary here, it's going to have the statistics for different French words. If we go to, I'll just go back to English. If we go to the default statistics dictionary for English, this has the statistics for different English words. So when you are creating a dictionary, make sure that you have the right language selected. Okay. Let's see, text analysis workflow. So for the next couple of days, we're going to focus a lot on text analysis. This is because text analysis is one of the primary strengths of PolyAnalyst. It's also one of the main reasons that we stand out as an analytical tool. So let's start out by talking a little bit about the text analysis workflow. So the first part of the session, we're going to review a typical text analysis process and its stages so that you better understand how to approach your projects, and also so you'll know what tools are available at each stage for the tasks you want to perform. So just to recap, one of our main goals of text analysis is to turn unstructured data into structured data. So in simple terms, let's say we have some records with what we call natural text or free text. So open-ended questions in surveys, online product reviews, insurance claim notes, things like that. And we may need to identify the important information in that text and turn it into a structured format that the computer can understand, such as a table. Then we'll have a format that's easier to analyze and derive insights from. So let's say someone gives us a data set containing free text, and maybe they've already posed for us one or two general business questions they want to answer using that data. So where should we start? So here's a diagram showing the typical stages of a text analysis workflow. We're going to briefly go through these. So first, the most obvious step is to load the data we're going to analyze into our workspace. For this stage, we need to know the file format of the data in order to use the correct node to import it. But we will also need to know the data types that we'll be working with. For example, are they strings, states, numerical values, or free text? We'll come back to these different data types later. The second step that analysts sometimes tend to skip is the data processing part. However, it's actually one of the most important steps in text analysis. This is where we're going to be cleaning the data. So even if we have, or as people say, garbage in, garbage out. So we need to make sure that the data we're going to be working with is of good quality. So we want to clean and process it as much as possible to increase the accuracy of the actual analysis. So once we have our data prepped, the next step is to perform what we call data-driven analysis. So in this step, it's all about getting familiar with our data, where we explore and discover the vocabulary and topics and information that we may wish to analyze in a more targeted manner in the analyst-driven analysis stage. So this is where our human knowledge comes into play for defining more targeted queries and organizing classification schemas, all of which will be based on what we discovered through our data-driven analysis. And remember, our goal is to transform unstructured data into a structured format so that the computer understands it better and we can analyze it further to get some useful insights. So after the analyst-driven analysis stage, where we extracted all the useful hidden information in the text and stored it in a structured format, we can now perform structured data analysis to address more targeted questions about our data and use that extracted information to glean insights, whether they're about what's happening now or whether we're trying to make predictions based on the current data. And finally, we want to present the results of our analysis in a meaningful visual manner and be able to communicate these findings across different departments and backgrounds, both technical and non-technical, and with PolyAnalyst web-based interactive reporting tools, make these accessible. So as a summary, these are the typical stages of a text analysis workflow, but in practice, the text analysis workflow isn't necessarily a linear is not necessarily a linear process like we see here. It's really more, we're going to be going back and refining at different stages over and over again. It's an iterative process. So that means that in practice, the actual text, which is iterative. So now that we're familiar with this process, we'll go through each of these steps in the client and see how we go about doing them. The first of which is data loading. Let me check time. I believe I have a break scheduled. Yeah, let's go ahead and take a 10-minute break.
Summarize. Sorry. Bring them together.
All right, so it's been about 10 minutes, so I'm gonna start back up again with the first step of the text analysis process, which is data loading. All right. So there are two important things to consider when loading data into PolyAnalyst. First, what type of file do we have for our source data? Or where is that data located? Is it in a CSV file? Is it located in a database or on a website? This will help us choose which data loading node to use. The second consideration is what type of data do we have in our files? Is it text, numbers, dates, strings? This is important to know because it affects what types of operations we can perform on the data. Now, in many cases, the data loading nodes in PolyAnalyst automatically identify the type of data in your data set, and it subsequently standardizes or normalizes the data during import. However, we can also choose to manually change the type and format of the data, giving the user additional control over how the data is imported. And while we usually have a single data source, we can also combine multiple data sources with data manipulation actions, such as joining or merging data sets, which we'll talk about those more during the data manipulations section. All right, so here we can see the different data types that PolyAnalyst uses. And also you may notice that each type of data has a sort of symbol associated with it that you will eventually need to recognize while using PolyAnalyst, or at least it's very helpful to recognize these symbols. Now, in the PolyAnalyst analytical client, we have a data sources grouping in our node panel that's dedicated to the nodes used for importing data. This group contains nodes for loading all kinds of file formats. In addition to popular formats like CSV files, there's nodes compatible with Microsoft Excel and Access files, nodes to connect to databases, nodes that bring in emails and email archives, nodes that access social media sources like Twitter, as well as nodes for scraping data from online sources. Now, in this training, we're just going to focus on some of the nodes you're most likely to use in your projects. But if you have questions about any of the other data source nodes, you can let us know. We'll try to take a look at those. So the first node we're going to talk about is the CSV source node, or the comma separated values file is a very popular data file format because it allows for some structure in the way we store our data. So when you import it, it shows up as a table with columns and rows. The CSV source node in PolyAnalyst can be configured to import both CSV and also simple text files, and it allows other delimiters or value separators than just the comma. For example, there are tab separated value documents and semicolon separated value documents. The CSV source node gives you a number of encoding options. So if any of you work with different languages or online data, maybe with emojis, you know how important it is to have the right encoding option enabled. And finally, the node allows you to select the data type for each column so that the data in a specific column is interpreted in the correct way by the computer. We can also choose the format for each data type. So for example, for dates, you can stipulate whether to use year, month, day, or month, day, year. And we'll be returning to this node and its configuration requirements later. when we have the hands-on practice section. Another popular data source node is the file source. The file source imports folders of documents. These documents are then loaded as individual records. So in other words, the folder is imported as a table with each document in the folder as a row in that table. So this node can also import multiple document file types, including HTML and PDF. The files source node can be configured in the properties window. This can be done by browsing and selecting the folder we wish to import, as well as choosing the file types to include in the file masks box there on the right. And if you want to import a different file type that's not listed by default, we can simply type its extension into the file mask box here. However, there are certain limitations on the types of files that we can import. Finally, the Open Database Connectivity, or ODBC source node, allows us to load from a database and import data tables or the results of SQL queries. To access a database source using this node, you will need to have an ODBC driver on the same Windows machine where the PolyAnalyst server is installed. However, the database's file source can be on any machine as long as it's on the same network as the PolyAnalyst server. So here's what the node properties for the ODBC source node look like. Now, in order to access and connect to the database through the node, we need our access credentials for that database. At the top is where we would initiate entering that information. And once that connection is established, we can choose to import a table or a view from the database and specify other preferences. Alternatively, we can choose to manually enter an SQL query and import just the results of that query instead of a specific table. All right, so let's do some hands-on practice looking at the data loading nodes.
Hello, Jeff.
Yes.
Kindly hold on so that we can do a recap of what we've covered.
You'd like me to do a recap?
No. Oh, yes, yes.
Of the data loading section?
Yes.
Okay. I'll briefly recap data loading. So this is going to be the first step in pretty much every project that you work with in PolyAnalyst. Data loading is the process of taking the data you want to work with and loading it into PolyAnalyst so that we can perform other operations on it. There's two things to consider when we want to load our data. One is what is the type of file that we want to load, because that will determine which node we need to use to load that data. And the other is really once we're at the point where we're actually loading the data in to the node, there will be a section where we select what data type each of the columns is. And the system does try to automatically detect what the data type of that column is. So, an integer or a numerical or a Boolean. And it does a pretty good job with the automatic detection, but it's not 100% right all the time. And in that case, you want to manually check and may need to manually change. And we'll when we do the hands-on part, I will show how to do this. You can go and manually change it so that the data type of the column is manually changed to what you need it to be. And that's important because certain operations can only be performed on certain data types. So math operations, for example, can only be performed on integer and numerical data types. If it's a string, so you can have a number, but if it's stored as a string rather than an integer, then you can't perform a math operation on it. Instead, it's going to be taking text operations. So that's why when we first load the data, we want to make sure that each column of data is loaded as the right type of data. So there are a bunch of different nodes for loading different types of data. The node palette will have a section that is just all of the data loading nodes. The most popular of which is the CSV source node. It's used for loading CSV files, which are comma-separated value files. They are essentially tables where the structure is indicated by commas. So the system will know how to build a table from this list of terms that are separated by commas. There are other delimiters. There are documents that have tabs in between each table cell, but we don't have to worry about that too much. There is also a files source node. Rather than loading just a single, Word document or something, if you have a folder of Word documents, you can use the file source node to load all of those Word documents together, and that will create a table where each Word document is one row in the table. So it doesn't work exactly the same as you might expect some other data loading nodes. So for example, the CSV node, you select a single document and load it in, and the table is whatever the table inside the document is. The CSV is essentially going to look like an Excel type table, and that's going to be your table inside. But I wouldn't recommend trying to load multiple table type documents using a files node, because then each table is going to be in one cell of your data table. It's going to be very confusing. But this works very well if you have like multiple Word documents, multiple text files, multiple PDFs, things that are just a set of text. A long piece of text is a thing that makes sense to have in a single cell of a table. So yeah, if you have a folder full of similar documents, you can use the file source node to load them all in as a single data set. And this is sort of the UI for that. So it says select folder here on the left. You're going to type in you don't have to type it in. You can click the plus and browse to a folder and select it. You could actually select multiple folders if you want to load multiple. Let's say you have 3 different folders in different locations, but they all have documents that are of similar content and structure and file type. You could load all of them into a single data set. And over on the right is where we indicate what type of documents we want this node to load. So if you only want to load Windows Word documents, you can erase everything else except the docx part. Then it'll only load that type of file, even if there's other files in those folders that you selected. And then we have the ODB source node. So this is the primary way that PolyAnalyst interacts with databases. But in order for PolyAnalyst to interact with a database, you need to have an ODBC driver set up, which is something external to PolyAnalyst. You need to download a driver from whatever type of database you're using. If you're using a like a MySQL database, you need to get a MySQL ODBC driver and install that driver on the server where the PolyAnalyst machine is running. And you need to configure that through like the Windows UI. And then once you have that set up, then it works. That driver will work as the go-between between PolyAnalyst and the database. So PolyAnalyst will, PolyAnalyst will connect to the driver that you've installed, and then the driver can connect to the database and act as the go-between between PolyAnalyst and the database. And so the ODBC source node is really connecting it to that driver that works as the in-between. And then once you have that connection established and you're connected to a database, you can pull in tables that from the database, or you can actually write a custom SQL expression to pull in and create a custom table instead. Okay, so for hands-on practice, we have our project open, hopefully. And I'm just going to go to day 1 here. Do we have... Oh, I didn't do this. Well, we could do that too here first. I'm going to take a step back because I forgot to do the hands-on for the PA overview. So we have a list of things that we're going to look at real quick. So this is a CSV node, and it has loaded. Just by default, when you load in a data file, the name of the node will change to the name of the file that you loaded. So here we have a CSV file that loaded a file called cardata.csv. We want to view the results of the CSV source node. So to do that, we can just double click. And so here is the table that is stored in the CSV source node, or in the CSV file called cardata. We can see that, as expected, this is data about different cars. We see there's a model, and so model plus year is sort of a unique key for individual cars. And then for each of the, for the 70 Chevrolet Malibu, we can see what the miles per gallon, cylinders, engine displacement, power, or horsepower, weight, acceleration is for that car model. We have that for a bunch of different cars. There's some missing values. Sorry, someone have a question?
Kindly hold for a second.
Sorry, what?
Kindly hold for a second.
You have the exact amount of the shell. It is a clear that
Yes, I shared with Alicia so that you can share with the rest of the team.
everybody, we want to leave anybody. The exile of a shell is determined.
The zip file.
This one.
The zipped.
It's zipped. You have it. You have it. Anybody have it? Who doesn't have it?
Is there something I can show again to help, or?
No, we are just confirming that we are all on the same page. We're just confirming that each and every analyst has the training data set.
Okay.
So we all have practice. You can copy. Yeah.
Carry on, Jeff.
Karen? All right. So we were just looking at the results of a node that we had loaded for the first time. Let's do add a modified columns node and connect it. So the easiest way to add a node, if you know what the name of the node you want to add is you can just do a search for it here at the top. So I'm just going to type in mod and find modify columns and drag. As you can see, I click it here and drag it onto the workflow. Then when I let go, it will create a new node here. And then to connect them, I hover my mouse over the CSV node here. We can see that black triangle appears. And then with the mouse over the black triangle, we click and drag over here. And then when it sort of everything, when the second node gets highlighted with a box around it and the arrow kind of sticks to it, that's when we know we can let go. And it will then create that connection. And the status icon for modify columns will change here to yellow. That's because the modify columns node can be executed without without any configurations, although it'll just not do anything. So here we have execute modify columns node without changing properties. That's fine. So we can execute it in two different ways. In this case, there's only two nodes, so it doesn't matter which way we choose. We can, if I double click it, it will execute and change from yellow to green. We could also right click and do either execute or execute to here. Then we have rename modify columns node to practice one. So here we want to get in the habit of renaming our nodes, just so that it's always clear what they're doing. Although practice one's not super clear. So let me do that again. I'm right clicking the node to bring up the contextual menu on the node. Then we can go to rename here. Then I'll just type in practice one. Click OK. And I'm going to zoom in a little bit. So I'm going to hold down Control and use my mouse wheel to zoom in and make this a little bit bigger and easier to read. And then step 5, we want to group nodes. So we want to put these two nodes into a group. So I'm going to click and hold to highlight both of these nodes. And then we're going to right click and go to group. So now they are a single group. Then we want to go in the group node and go out of the group node. So to go into a group node is easy. We just double click the group node. And then to get out of the group node, right now there's only one way, and that is to click up here. So here we have a slightly longer address than we had seen previously. So and that's because we're down several levels. So we have the root. The root is the screen where it said day 1, day 2, day 3, day 4, day 5. And then we clicked on day 1, so we were inside day 1. And then inside day 1, there was like the sandbox and PA overview and data loading. So we clicked on PA overview. And now in PA overview, we have group node. So when we click on group node, that gets added to our address here. So to get out of the group node, we can just click on PA overview. Additionally, if we were actually working on a project, we might have incoming links and outgoing links. And double clicking on either of these icons will also bring us up one level back up to PA overview. Then we want to ungroup the nodes. So we can just right click the group node and go to this option here, ungroup. And that sort of deletes that folder, but brings those nodes back up to the same level. And then the other is open up the dictionary manager, which I briefly showed. But we can once again say there's two ways. We can either go to the drop-down menu at the top left and go to dictionary manager, or we can see that it's listed right here. The shortcut for opening up the dictionary manager is Control D. So I'm just going to press Control D. That opens up the dictionary manager, where once again we can see our server dictionaries and our project dictionaries. Okay. So that was PA overview. Let's move into data loading. So here we have some questions and an answer key. So part one, we want to find the CSV source node from the node palette and drag it here into the workflow panel. So I'm just going to do a search for CSV, find CSV source, click and drag here. Additionally, if you didn't, I would think you'd know that the CSV source node has the word CSV in it. But do take note that over here on the left, we have different icons for different types of node groupings. And this first one up here is called data source. So this is the list of nodes that load data from an external source. And so you can browse this list to maybe, if you're not sure what type of node you need, you can browse this list to get an idea of what might work for you. And here we can see there's the CSV source node. So we could also drag and drop from there. And we want to open the properties dialog. Let's go to the examples folder, import. Okay, so let's just, so this is going to be something that you do for many of the different nodes. After you drag and drop it onto the flow chart, we're going to want to right click it and go to properties. As some nodes, you can, when it's red like this, you can double click it, and that will also open up the properties window. And now it may give you a pop-up here. So this is not the properties window exactly. It has opened up the properties window and then detected that this is a data source node that hasn't indicated what data to load yet. And so it is asking us to browse for the file that we want to load. Now you may need to try and remember where that data is that I sent. So I sent like a data.zip file that had all of the data sources used in this project. I'm not. Do I have? Do I have them here somewhere? I may need to grab that data and put it on this server real quick. Or no, well, okay. So this won't be the case for all of the data sources, but this particular data source is in the examples folder. So every PolyAnalyst installation comes with an examples folder, and it just has some generic data sets that you can play around with. And one of those is the car data set. So I'm just going to the examples folder and car data and clicking OK. So once I click OK, now we can see that this CSV source node is going to be loading card data.csv from the examples folder. And what's it want me to do? Okay, it did want me to go to the examples folder and import card.csv. And then I double clicked it to execute it. But when you're in the properties window, you can also click execute here, and that will execute the node. And we can see that we have successfully executed, but there is a warning error. And so our next task is to check the log and see what the error is and then fix it. So to see what that error is, we're going to right click the node and go to view log. We go to view log and we have a single error that occurred, and we can see that it happened in the displacement column at row 59. There's a conversion error. The intended data type was an integer, but the source data type was 97.5, which is not an integer. So let's see, it's a 59, row 59. So then if we go back and we open up the results of our imported node and we go to row 59 and we go to displacement, we can see that the cell for displacement is null. It tried to load in a numerical number as an integer, and as a result, it imported nothing. The cell is null. So how can we fix that? Well, now that we know that that column has numerical values in it, we are going to let the system know, because once again, if we right click on the node and go to properties, and then we go to column specifications, this tab up here, and then we have to click refresh. When we click refresh, it will re-access the file and list out the columns that it can see. So now we have a list of all the columns in the data set. We can see here for displacement, it is loading displacement as an integer. And the reason for that is that it's looking at like the first X number of records and sees that they're all integers, and so it just assumes that they're all integers. We have to do that because there are documents that are millions of records long, and it would just be very slow if at every step everything had to read all of every row in the data set. So we have many parts of the system are built to run fast no matter how big the data set is. And in this case, it does that by only looking at some of the records when it's trying to decide what data type to pick. So here we're going to manually change this from an integer to a numerical. And then we can just click execute again. And now there is no longer a little warning symbol. And if we double click it and go to row 59 where we already are, now we can see that we have a 97.5 for our displacement value. Okay. Any questions about any of that? So numerical, yeah, numerical is like float, yeah. So if you have a numerical, if a number has a decimal, then it needs to be numerical. Integer is for no decimals. Just a few other things. So in the slides we had mentioned encoding. That's this option here. And we'd also mentioned, well, let's try for date. Is it? Oh, never mind. All right. Any other questions? Otherwise, I think we go to the next section, which is data pre-processing part 1. Okay, let's do that. All right. So then we're going to move on to the last topic for today. We'll be covering how to use just a few of the nodes that are frequently used in pre-processing the data. And there are many other nodes that are useful in pre-processing, but we'll be covering those in some of the other sections. Many of the nodes can be used in more than one step of the process, so there's a little bit of leeway in what gets discussed where. So, as you likely know, the raw data we collect is not always perfect. There may be formatting we want to change, errors we need to fix, categories we want to combine, or attributes we want to derive. This process of making the data more useful and readable is often referred to as cleaning the data. So these are the 4 nodes we're going to be covering in this section. We have the replace categories node, the replace terms node, the derive node, and the extract terms node. So replace categories is used exclusively on categorical data and allows you to replace one categorical value with another. Replace terms can be used to replace patterns in text or strings. The derive node works with metadata with many data types and is used to create new columns by performing some operations usually by taking other columns as inputs, though not always. So for example, getting the sum of the values of 2 columns or returning a yes or no evaluation based on some test. And finally, the extract terms node, which allows us to extract patterns from the text to create a new string column typically, or text column. And we're just going to go straight into the hands-on for these. So still day 1. Here we're in data pre-processing part 1. And we should see something like this. These should be executed. Let's see. So here we have a data set. This is just a tiny subset of an existing data set. This is just 50 records from our National Highway Traffic and Safety Administration data set that we use sometimes as an example, because we don't need a huge data set just to test the basic functions of these nodes. But let's take a look at the data just to get an idea of what we're working with. So this is data taken from some car accidents, and it has information about, there's a text column here that describes the accident about, it has occasionally has information about how fast they're going, if their tire blew out, where they were going, things like that. And then this data set was about a specific tire that was having issues. So that's why it's all tire related. So we see the tire model, tire size, the vehicle type, the vehicle manufacturer and the vehicle model, and then whether or not the tire blew up. And the first task we have here, my resolution's a bit off. So sorry, if you can't read these, you can double click it to read it, or we can make it a little bit bigger. Oh, that's unfortunate. Let me expand these real quick to make them more readable. Even though it's a little bit ugly. Okay, yeah, sorry about that. Oh, that needs to be more. Okay, make sure these are all okay. So, question 1, in the blowout column, replace values with yes, no, or blank as appropriate. So, I'm going to look at this replace categories node. We're working with replace categories. What this does is it's going to list out all of the different responses for a string type data column. And then we can look at all the different responses and sort of consolidate them and normalize them. So for the blowout column, let's say keep this source column intact. Okay, so keep the source column intact. So by default, it's going to keep the old column and also create a new column, in this case called blowout _ rep for, replace columns. You can double click this and change the name of the new column if you want, or you can click drop source and that will replace the old column values with the new values instead of having an old column and a new column. But for now, we're keeping both columns. And then when we click on values map, these are all of, so this input column here, these are all the different values that are found in that column. So we have N, NY, NA, UKN, UNK, and Y. And our instructions said to replace each of those with either yes, no, or a blank. So to do that, we go to the output and I say for N, we can say no. And then for N/Y, it's not really clear what that means. I'm just going to leave it blank. So I'm actually going to discard it here. Same with NA, unknown. These are unknown and unknown, but abbreviated differently. And then for Y, we're going to put in a new value of yes. So when we discard these, they will go to be blank. Yes. Are the analysts supposed to do the same? Yeah. I do recommend that everyone follows along with these as best they can. I'll try to sort of do the whole thing twice, so that people can try to follow along with it while I'm doing it. But if they get behind, they can wait for me to do it again. Then I click execute. And so now when we double click it, we can see that we have these two columns here, blowout and blowout rep. We can see that all the Y's have turned into yes. And all of the weird things like N/Y and unknown and NA, those are left blank. And all the N's are no's. So we've just taken the different values that we had before and just replaced them with other values to make it look cleaner, instead of having like 5 or 6 different ways that people were saying they don't know or is unknown or it's not applicable. Now those are all just blank. So let's go through that again. Let me No, well, it's probably going to remember my settings, but that's okay. So once again, the task is to look at the blowout column, and we want to replace, we want the only three values at the end. It should be yes, no, or blank. So we're going to look at properties, and we're going to drag. So this is a UI that you'll see pretty frequently in PolyAnalyst. On the left, we have available columns. So these are all the different columns in the data set that are allowed to be worked on by this node. And this replace categories works with string columns. So all of our string data type columns are listed here. And one of those is blowout, which is what we wanted to work with.
Hi, Jeff.
Yes.
Hi, Jeff. I think there's some questions in the chat. Could you as well look at them?
Yeah, they are analysts supposed to do the same. Yeah, if you have, I suggest you have PolyAnalyst open during any of the hands-on portions that I'm working on. I suggest that each of your analysts has PolyAnalyst open and try to follow along and copy what I'm doing, so that they can also
Yeah, because you've gone so fast. So is it okay if you just start from the beginning then? Because the answer is the most important one. So you have a couple of questions. So as you can see, question one. Can we just stick to question one and then confirm that everybody is doing question one?
Yeah, I'm still on question one currently. So we're not too far ahead yet. I'm currently doing question one. So let me start over once again with question one.
Yeah. Okay. Fine.
So I introduced this section. We're working with some car crash related data with tires. So that's the data set we're working with. Our question one is, so it wants us to look at our blowout column. So if I look back at our data set that we're working with, there's this column here called blowout, and there's a Y or an N to indicate yes or no for whether or not the tire had blowout, whatever that means. So we can see, the summary says tire blowout, and then in the blowout column it says yes, it had tire blowout, right? But if we look at some of the other responses in the tire blowout column, we have N/Y, UKN, NA, and UNK. So we have some sort of non-standard responses that we don't want to see. So in order to clean those responses up, we're going to use this replace categories node. So our task here is in the blowout column. We want to replace all the values such that the only values that are left are yes, no, or just blank. And we also want to keep the original column intact. So we want to have the old column and a new column with our new values in it so that we can compare them. So to do that, I'm going to right-click the node and go to properties here. And then on the left here, we have a list of all the available string columns. So replace categories only works with string type columns. And so these are the string type columns that this data set has. But the one we want to work with is blowout. So I'm going to drag that over to the right here to the selected columns list. And now we can see that the name of the column is blowout, and we are going to create a new column called blowout_rep. And that's what we want. So then the next step is to actually look at what values are in that column and choose what to replace them with. So to do that, we're going to go to the values map tab up here. And I'm going to reset it to what it looked like at first. So this is what it looked like originally. So it's just listing this input column here. this is a list of all of the different values in that column as it already exists. So we have, most of them are N or Y, but we also have these junk answers that we want to normalize and consolidate. But we also wanted to change N and Y to be yes and no. So to do that, I'm going to change what the output is. So there's this output column over here. So instead of N, we want no. And instead of Y, we want yes. So we've done one part. But then for all of these, we want them to just be blank. And the easiest way to do that is to check this box here. So this column over here is called discard. And if you check the box in the discard column, it will take any of those responses and just make them blank. So now if I click execute, and if I click on the results of this node, now we can see that instead of, so originally we just had our blowout column, and that has been left unchanged. But now we have a second column called blowout underscore replace. And these are the replaced values for that column. So all of our Y's have been turned into yes. All of our N's have been turned into no. And our NA and our UNK have been turned into a blank. Now, maybe you don't like blank, but you still want those all to be the same response. What we can do instead is turn them all into NA. Something like this. And this is already NA. So when I execute, so now we're not discarding anything. We're just replacing this one with NA, and this one with NA, and this one with NA. And in this way, we can consolidate those four. So now when we look at the results, we just have yes, no, and NA. Okay. Does anyone have any questions about that? Okay. Let's move on to a different case. So working with the same car data, we're looking at question 2 here. Also, we're going to be working with replace categories again. So,
Hi, Jeff.
Yeah.
So I'm just asking the analyst if they're okay, because you said they do question 1. Is this something you want them to finish before we move to question 2, or what will be the best way?
If people are still on question 1, we can wait a minute. If they need help, they can ask a question.
Anyone with question from question 1? Sorry. Yes. So Jeff, I just wanted them to do the question 1, and we hold for the first question before we go to question 2.
Sorry, say that again.
I just wanted the analyst to do question 1, and because we're here to support them, so we check if they're okay before we go to question 2.
Yeah, yes.
We hold, and yeah, we just want to cross-check with them that question 1 they have, and they can do the replace categories the way you've explained.
Okay, so they are ready for question 2?
No, I want to check with them individually so that we all proceed together.
Okay, yeah, let me know when everyone's ready, or if anyone has any questions.
Okay, so check.
So someone is asking a question. Are the changes reflected in a new column, or do they replace the current column? And the answer is that you get to choose which of those you want. So by default, when we're looking here, we have name. That's the name of the column we're working with. And then there's this column here called new name. So that's going to create a new column with the changes, and the original column will remain unchanged. So we'll have a new column that's the same as before, or we'll have the old column that's the same as before, and a new column that has the changes. But there's another option. There's this checkbox here called drop source. If we check this box, it will replace our old column with the new values. So we'll still only have one column, but it'll have the replaced values in it instead of having an old column and a new column.
Okay.
So we can move to step 2. Jeff.
Yes.
Jeff. We can move to question 2.
Okay.
Okay.
So similar to question 1, we're going to be using replace categories to look at the values of a categorical string column and then do some cleaning, some consolidation. So in the tire model column, we want to replace any of the models that are related to wilderness. So wilderness AT, wilderness HT, etc. And we want to combine them all under just the simple name wilderness. So if we look back at our data set and a very useful view in the data set. If we go down here to these tabs at the bottom, there's a distinct tab. This is very helpful. If we go to distinct and then we click on, what was it, tire model, this will list all the different values in the tire model column. So we can see that the different tire models are ATX, Wilderness AT, Wilderness UNK, and Wilderness HT. And these are the values that are going to show up in our replace categories node when we look at this column. And what it's asking us to do is to take Wilderness AT and Wilderness AT, Wilderness, and Wilderness HT. We're going to combine all 3 of those into a single category that's just called wilderness. So to do that, I'm going to right-click on Properties. And then from our list of available string columns, we're going to pick Tire Model. And it doesn't say if we want to keep the old column or not. So I'm going to continue to create a new column and keep the old column so that we can compare them. And now we go to values map. And like I said, this is going to list out all of the different values that are found in that column, as we saw in the data set. So ATX, we're not going to change. Unknown, we're not going to change. Wilderness, we're not going to change. But I am going to copy paste the text so that I can. And then Wilderness AT, we want to combine with Wilderness, and Wilderness HT, we want to combine with Wilderness. So we're just taking these values over here and replacing them with these values. So then when I click execute and double click the node to view the results, we can see here are our 2 related columns, tire model and tire model rep. So we can see all the wilderness ATs and wilderness HTs have just been replaced with the more generic name wilderness. If we go to distinct and compare, so before we had 5 different categories and ATX was 40% of our data. Now that we've combined all the different types of wilderness tires, now there's only 3. Well, and one of them's unknown. So there's really only 2 models. And now wilderness is taking up 54% of the data. So really wilderness was the most common type of tire. It was just split up amongst more specific brands, more. Yeah. Okay. Do we need time for people to finish looking at that? Let me just, I can go through it again. So just real simple. We want to consolidate the names of the different models of tires. So I'm taking the tire model column and putting it on our selected column side. Then we're going to the values map. And this is what it looks like initially. It's just listing our 5 different outputs, or the 5 different values that it found in that column in the data. And we are leaving ATX and unknown alone. But for wilderness AT, we're deleting the AT. And for wilderness HT, we're deleting the HT. And so these 3 categories are going to all be combined into a single category because they all have the same name of wilderness. And we execute, and we end up with these 2 columns. We have the original column here, which has the specific tire models of wilderness AT and wilderness HT, as well as some that just say wilderness. And then we have the new column where those have all just been replaced with the generic term wilderness. Okay. Let me know when we're ready to go to question 3.
It's easy. Yeah, let him pause and say that. How many people are floating? How many people are on board? How many people are... Yes, replacing. See there, when you open that node, when you open that node,
Let's move on, Jeff. Hello, Jeff.
Hi, yes. We can move on
Yes.
to question 3.
Can I move on?
So now we are working with a different type of node. We're going to be working with the derive node. It's a very flexible node. The purpose of the derive node is essentially to make a new
1
column.
minute, Jeff.
Yes?
1 minute. 1 minute.
Oh, 1 minute. All right, sure.
Hi, Jeff.
Are we good?
Yes, hi, Jeff. So because we started the add-on today, the question is, can we just review what we've done so far and a recap of what we started with in the beginning, and we can carry on the rest of the hands-on tomorrow, the first thing, because it's already 5 o'clock our local time.
Oh, do you I was under the impression that we were doing 3-hour sessions. So we want to do like from 2:30 to 5, 2.5 hour sessions from now on?
Yeah, we can only start at 2, but of course, because today is the initial day, we've started the training, and we don't want to load so many things in the beginning. I think the most important thing is covering the initial steps, and then now we can proceed. I think tomorrow and the day after and till Thursday, we can start from 2 o'clock because
Oh, you
everybody's
want to start? You want to start earlier? You want to go from 2 to 5?
Yes, 2 to 5.
Okay, so starting tomorrow 2 to 5.
So
Okay.
today is 2.5, and then the rest of the other days we can catch up. I think the most important thing, hands-on is the most important thing. What do you think?
Sorry, what did you say?
Maybe we just spend 5 minutes recap of today's.
Sure,
And,
sure.
Yes, and then we carry on from question 3, first thing tomorrow.
Okay, sure. Yeah, let me quickly recap here.
Yeah, just a quick recap.
Let's see. I guess we don't need the slide. So mostly at the start, I just introduced PolyAnalyst. It's a all-in-one tool, so you load data, process the data, analyze the data, make reports all inside of the client. Then we went over importing projects, and then we started looking at the UI a little bit, looking at making group nodes and connecting nodes into our flowchart. We also talked about the architecture, the server client architecture of the system. We talked about how you can use either the thick client or the application itself, or you can use a browser and a thin client, the pros and cons of that. We talked about execution waves, so the order that nodes are executed and why you might want to control which nodes are executed in a project. Execution waves. We talked about dictionaries. We haven't really looked inside any of them too much yet, but know that there are dictionaries that are structured lists of words and related things that help PolyAnalyst make sense of things and also give us some shortcuts when we're working. And then we talked about the text analysis process, how it's iterative. Then we went into data loading and talked about some of the common nodes that are used to load data, especially the CSV source node. And then we have started our data processing section where we're looking at some of the nodes that actually let us manipulate the values in the data and create new columns. And we covered the replace categories node, and now we're working on the derive node, which we're going to see lets us create new columns using some expression we write. And that's where we'll pick up tomorrow. Apparently, at an earlier time, we're going to be starting at 2 your time, 7 my time. Is that we're good?
Okay.
I guess that's it. That's it for today. So everyone have a nice day.
Thanks,
you,
Jeff. So we catch up tomorrow from 2 our local time. Good.